Good morning, everybody. My name is Julie Beaver, and I'm working on my problem-solving video for Math 626. And so looking at the definition that my group came up with for problems, we decided that problems are questions that require a solution. Acquiring the solution provides individuals with the opportunity to apply not only mathematical skills, but problem-solving strategies in everyday life. So as I was thinking through a problem that I wanted to solve, I thought, what could be better than trigonometric proofs? So today, I'm going to help you prove that sine of theta over 1 minus cosine theta minus 1 plus cosine theta all over sine theta equals 0. So the first thing we're going to do is understand the problem. What even does this want me to do? Do I have to have a number answer? Am I just combining like terms? Do I even have like terms? What kind of solution should I be getting, and what exactly is the context of this problem? Could I move something over and cross multiply? What can I do? What is legal? So what this question in this context wants me to do is just to prove that all of this stuff on the left side is equal to all of this stuff on the right. So my goal is to take this whole equation on the left and to simplify it and to prove that that actually equals 0. Not to find the different thetas that it works for, although that might be valid on a different day. Right now, all I need to do is show that what's on the left is equal to what's on the right. So in order to do that, I need to devise a plan. So I'm going to look at general strategies for proving trig identities. The first thing I want to do is start with the side that is more complicated. So if I look at this, there's obviously one side that is more complicated than the other. Then I think, okay, I'm going to end with the side that is less complicated. Well, that would follow from the first one. And then each intermediate step must be easily seen as equivalent to the previous step. So I can relate that back to algebra. When I am just trying to solve one side for the other, I have to show that each step can come from the previous one. Now that said, this is a good plan. I want to start with the side that's more complicated and with the less complicated side. But what are some ways that I can work through trig functions and figure out how do I simplify them? Well, I have some specific strategies. First of all, I should always, my old standby, go to converting to sine and cosine. So I'm going to look back. Is this, oh, hey, look, I already have sines and cosines. So in this case, that's not necessarily going to be super helpful for me because I'm already there. That might work better if I had a tangent or a cosecant, something like that. I'm going to, after that, check, hey, can I combine terms by getting a common denominator? This works well if you're going from 2 terms to 1. Well, is that my case here? It is. Now, say I didn't recognize that right away. I could split apart a 1-term expression by putting the denominator under each term of the numerator. That isn't helpful this time, but it's a good strategy to know. I could multiply by the conjugate. Now that might sort of happen in this problem, but it's just good to know what a conjugate is and how I might use that. I might at some point in time also factor an expression, and there's a whole bunch of different ways to factor things. And then last but not least, if I'm not sure what to do, I can be creative, but not too creative because I still am bound by the laws of algebra. So as I look through these things, I decided that number 2, right here, combining terms by getting a common denominator, I think that that's going to be the best, strategy for this particular problem. So let's go back to it. Right away, as I'm looking to prove that this trig equation is equivalent, I want to think back, what else could I do? First of all, I know I'm going to have to be somewhat persistent. But as I look at it, I also want to maybe see, what do I know already that makes this happen? Well, a couple of things. If I think way back to 6th grade, if I had a problem like maybe 1/2 plus 1/3, I can't just add that together to get 2/5. So what are some things that I already know about basic operations and fraction problems? I know that I have to get a common denominator. Now, in order to do that, I see that my least common denominator between those two would be 6. So I would multiply this side by 3, and if I multiply the bottom by something, I have to multiply the top by that. And then over here, to get 6 on the bottom, I would multiply by 2 on the top. Now that I have common denominators, I can then add them together to know that I get a total of 5/6. Now, does that work for this problem? And I would say that yes, I can still work with that. At the same time, I'm going to change it over into a simpler problem. If you've made it to pre-calculus, then chances are you're generally a pretty strong algebra student. So what I'm going to do, I'm going to take these things and I'm going to abbreviate them. And I'm going to abbreviate sine theta as S, and I'm going to take cosine theta and I'm going to write that as C. So I'm going to make an easier problem and just simplify this. So I've got sine theta, so I'm going to write S over 1 minus C minus, and that minus is going to be super, super, super important right there. I'm going to say, okay, now we've got 1 plus C all over S, and that equals 0. I don't want to forget about the 0 part. Now, in algebra, this right here seems like a simpler problem for me to solve. So I'm going to use some color just to be able to differentiate where things are. Now, as I do that, I'm also going to personally talk through it verbally. I have found sometimes what my eyes see isn't always as helpful as what my ears hear. So verbalizing the process sometimes is very, very helpful for me and a whole lot of students. So when I look, I've got 1 minus cosine and I've got sine. So I think to myself, okay, what is my least common denominator? Well, my least common denominator is going to be S times 1 minus C, or sine times 1 minus cosine. So if that's the case, how do I get a common denominator on the left? Well, I'm going to multiply the bottom by S, or by sine. If I multiply the bottom by something, what do I have to do to the top? You've got it. I have to do that up there as well. Now, as long as I'm in that process, I'm going to look over to the right side, and I see I already have the sine, so what do I have to multiply by to get that to the common denominator? This one, I have to do 1 minus C, or 1 minus cosine. If I do that to the bottom, I have to do it to the top. All right, now I'm going to go through and simplify all of these things. On the left fraction, I have S squared. Then I have a minus sign, and I'm going to make that in red just so I don't forget it because something important will happen there. Then over here, I'm going to look, and I have 1 plus C. I have to make that in parentheses. That's an important piece. Times 1 minus C. So again, think back to my algebra skills and think, okay, what happens? What is that called right there when I have 1 plus something and then 1 minus something as well? It's a difference of squares, and so if I were to multiply that out, 1 plus C times 1 minus C, you will see that 1 times 1 is 1, but then when you do your inside and your outside, I get plus C minus C, depending on the order you do it, but we know by which property that order doesn't matter. You've got it. When you've got the commutative property, you can add in any order, so it's all right that I've got those. They cancel out, and then I get minus C squared. So here's where that minus comes in, and I'm going to put this in parentheses because I've got minus the total of 1 minus cosine squared. All right. Now, at this point in time, I got a common denominator, so I'm going to write everything over the common denominator. So I've got S times 1 minus C, right? So again, what I've done is I've taken this trigonometry with sines and cosines problems, made it into an algebra problem, which I'm much more comfortable with. Now I think back to my algebra rules, and what happens when I have this minus here? Well, I have to distribute that here and here. If that's the case, I now have s squared minus 1 plus c squared all over s times 1 minus c. At this point in time, I'm going to transfer it back into trigonometry because there are some things that I know that are going to help me. So I now have sine squared theta minus 1 plus cosine squared theta all over sine theta times 1 minus cosine theta. Now, if you have worked through some trigonometry in the past, you will know that something beautiful is going to happen right here. See this sine squared and this cosine squared right here. When you add those together, that is going to give you positive 1. If you're thinking, how does that happen? Well, this is called my unit circle. And the reason it's called a unit circle is because any radius on this circle is 1. So I'm just going to draw one example. If I have a right here, I know that the sine goes up and down and the cosine goes right and left. Now, I know that because it's the unit circle, this right here, the hypotenuse is 1. Now think about that right there. The sine and the cosine are making right angles to each other. What do you know of? Is there another problem, some kind of thing that you could use that would tell you, oh, of course, that would be 1. Well, if you look at that, it's a Pythagorean identity right there. So the cosine squared plus the sine squared would equal the hypotenuse squared, 1 squared. Then when we square root it, it equals to 1. So up here, look at this. I have 1, then minus 1 all over sine theta times 1 minus cosine theta. Now, look at this right here. What is 1 minus 1? Yes! If I do 1 minus 1, I get 0 over sine theta times 1 minus cosine theta. Now, back to what we were originally trying to do in the first place. We were trying to prove that this equals 0. Well, what do you know about 0 divided by anything? 0 divided by anything is 0. So, have I gone back when I was understanding the problem? What was my goal? My goal was to prove the left side was equal to the right. Have I done that? Yes, I have, because 0 divided by anything is 0. So now, I'm going to say, okay, can we check the result? Can we verify the solution? Can we check the argument? Could we have solved it a different way? Has their solution process and the resulting answer been expressed in the simplest and clearest way possible? Well, I went back, so let's see. I took my first thought process, I moved everything in over to algebra. Now, because I'm writing on a touchscreen computer, it's possible that it would be clearer if I was writing it on paper. But did I transfer everything over correctly? I did. Did I use my mathematical knowledge of creating common denominators? Yes. Did I use my algebraic knowledge of the distributive property? Yup. Did I get my sign right? Because signs everywhere are signs. Those are challenging at all times. But I did not miss a sign. Did I use my Pythagorean identity and use some knowledge of geometry and the Pythagorean theorem? Yep. All right, so I got 1 out of that. 1 minus 1 is 0. Is that what I was looking for? That was what I was looking for. So I have solved my problem. I have solved it with as much clarity as possible. So my final solution is that 0 equals 0. I have proven that to be true. And all is well in trigonometry land.